where it came from and how it all started, and then into Volatility 3 itself, and kind of the present day. And then Andrew will be carrying on the rest of the talk with kind of the new features and where we can go with it and how it's going to, expected to develop. So this slide hopefully gives you an idea that Volatility 2 has actually been around a really long time. Volatility itself was a concept that kind of came around in 2006 as FatKit, as written by Nick and Aaron over there. And it turned into Volatools, and then it became Volatility 1.0, and kind of started developing from there. I actually joined the organization somewhere in the 2009 area, so before Volatility 2 got released, but after Volatility 1.3 had come out. And I kind of joined it accidentally because I started doing an address space for live memory forensics on FireWire. And then I started just cleaning things up a little bit, and then I started looking a little bit deeper into the new things they were doing, and then suddenly it sort of snowballed from there. And we got Volatility 2 coming out with XP support, Volatility 2.1 coming out with malware and 64-bit support, and every year or so, actually, we jumped a bit and did a 6-monthly release. We're coming out with new features and released extra bits and pieces. Somewhere around 2012, 2013, we started saying Python 2 is going to go out. Python 3 has been out for like 4 years. We probably ought to start jumping on that bandwagon. And unfortunately, it took us a really long time to get there. But we continued supporting Volatility 2. We had the plugin competitions. We added Mac support and ARM for Android. The Volatility guys, the other devs wrote themselves the Art of Memory Forensics book, which hopefully many of you are familiar with. We constructed the foundation, the charity that looks after Volatility. And in the background, we were plugging away at getting the third version in place. I kind of dropped off the map quite a bit because I got my head down and was like, right, we need to do Volatility 3. We need to get it with Python 3. We need to not have any of these bits that are really slow and make all these improvements and stuff like that. I did come back once or twice. I gave a talk at OSDFCon in, I think it was 2015, about the unified output format, which we added or almost backported to Volatility 2.5. But it was a feature that we kind of designed and implemented with the concept that it was going to go into Volatility 3. And looking back at my old slides, I had listed out API endpoints and all kinds of things like that. And I saw it again recently, and I was really surprised that it actually stuck to almost everything I said I was going to achieve. So, Volatility 3 is kind of what I'd hoped for. But it as I say, it took us a really long time to kind of get ourselves in order. But today is the day, and hopefully we will get a release. To give you another small history lesson, back in the day, in 2006, when FatKit was first created, the memory samples, people's memory went up to maybe 4 gigs if you were really expensive and wanted to, flash your money about and stuff like that. And of course, these days, usually consumer systems come with 16 gigabytes of RAM minimum, and your server systems can go up to like 128 gigs, 256 gigs, larger and larger memory images. Also, back then, you would have maybe, memory forensics was kind of an unknown art. People were sort of there going, oh, yeah, that sounds like a good idea. We should do memory forensics, but we're going to do disk forensics. That's what we're going to do. And so you'd get like one memory image coming out every once in a while, and people would go, oh, yeah, we'll definitely draw good things from that. And of course, now you're getting 5 plus, 10 plus memory images from any instant or any situation that you're called into. And back then, in the early days, Volatility had a very, very small number of tasks that it could accomplish. And since then, and thanks to the community with Volatility 2, we've now got certainly more than 50 plugins, and you may very well run a good number of those on any instant that you're involved in and trying to work towards. So the landscape of kind of what memory forensics was when Volatility started through to what Volatility is, or what the landscape is now, has changed dramatically. Memory's increased. I think the number of memory images that you get has increased. And also, the environment around the world has changed. So operating systems, both of the major ones, have started moving towards a kind of a rolling release towards security. So previously, where you'd have maybe one operating system and it'd sit there for 3 to 5 years, and then you get another big release. Windows 10 has now gone to twice a year, changing out kind of big feature releases. The Fall Creators Edition and various bits and pieces like that. And with those can come kernel changes, and with kernel changes can come differences in how you analyze the memory, and that becomes very difficult for something like Volatility 2 to be able to handle. Also, with the Linux releases, just the last 4 releases that have happened in Linux have all been in a 60 to 70-day time period. So they're changing very rapidly, and being able to keep up with that and be able to deal with it more easily is not something that Volatility 2 was particularly great at. Building profiles was quite painful, and there was some difficulties around. We don't want that many profiles. This is one of the reasons that we had the Windows 10 _ this long hex number, because there wasn't really a way of saying, this is Windows 10, but it's not quite the Windows 10 you knew. It's now a slightly different Windows 10. Whilst it seems like maybe that we've been keeping very quiet about Volatility 3, the GitHub set of commits from Volatility 3 shows that actually the first commit was made in November 2012, and whilst it got off to quite a slow start, I have to admit, as of about 2016, things started picking up. We started getting a lot more commits coming in. The framework really took shape and kind of solidified, and then we needed to start getting all the plugins written for it and things like that, and it needed a lot of kind of tidying and cleaning and making sure that it all worked. But the idea behind it was to look at what we had done previously and how it worked and how it didn't work, and try and improve it and make sure that all those pain points, all those friction things that we know about, that we don't like, I'll get to one of those in a minute, just aren't there, just go away, because there's no need to have them there. If we sit down and think about it and design it properly from the start, then we can come out with a much better tool. So what's new in Volatility 3? Everything. The entire thing is new. The only thing that is the same is the concepts behind it. So even actually some of the names for the concepts have changed. Previously, you would know about address spaces. Those are now called layers, because it's not a single static list of address spaces. It's actually a tree made up of various layers. And the name kind of fits better what actually goes on. Instead of profiles, you have symbol tables, because a profile is good and you can kind of vaguely fit it, but symbol tables are specific to a particular operating system, and the point is that you can have more than one symbol table. So an application might have a separate symbol table to the operating system, to something else, to a different application. Every single line of code has been rewritten, which was definitely the right thing to do. I love the Volatility 2 framework dearly. I spent a lot of time writing big chunks of it, but I really wanted to make sure that having been through that and having written a large piece of open source software, we actually started doing things a little more, not formally, but just a little more maturely, more kind of as a software development thing. And the entire framework has been rewritten, therefore. So plugins, backend, everything like that has been rewritten. Since the concepts are very, very similar, porting over plugins and changing them to work with Volatility 3 shouldn't be too difficult. But the idea is that it will give you a lot more support and structure, and it's actually been designed to work as a framework. So the first big thing is that it's been written in Python 3. This kind of had to happen. It was sort of the initial starting point for Volatility 3. But some of the other nice things that we've been able to add are massive speed boosts, because Volatility 2 was originally designed with the concept of probably a misguided concept of working directly with live memory with live memory images through FireWire or some other kind of PCIe device or something else. And therefore, every time you asked for a piece of data, it would go back to the disk and reread it and then tell you, oh, here's that data, which is great if in the 1.0 0% chance of actually doing live memory forensics. But by and large, everyone used disk images of memory images. And so you'd end up, I'd do profiling on Volatility and see that it was doing like 1 million reads for a simple loop of PS list or something like that. And that was because every single time it asked for the guard variable on the loop, it would go back to the disk and it would look up the DTB and it would find out where the DTB was and read that bit off disk and it would go through all the page tables and it was just thrashing the disk. And it turns out that Windows Disk I/O for really small reads is not all that efficient. So that was a massive trouble that we had with that. And with Volatility 3, we said, actually, what we're going to do is when you construct an object, we'll read the data in then, and it'll stay that way, and the Python object itself will keep that data. And then if you need to reread it again, you can ask it to reconstruct itself or do something else. But the point is, that's a very, very uncommon task. And the speed gains that we got from that were enormous. And similarly, actually, just by running in Python 3, version 3.7, the Python developers managed to introduce a vast speed up in certain aspects of Python itself. So all of these things help us make a much, much faster system. And we'll get some examples of how much faster it is in a little bit. It's also actually been designed as a library. We called it a framework when it was version 2, and we said, oh yeah, the idea is that you plug all this stuff together, but what we actually wrote was a command line tool that everyone used, and then they kind of scraped the output. And then we said, oh, scraping the output sometimes loses bits, so we tried to improve the outputting format stuff, which was great for unified output. But for anything that still used text output, you'd have to do manual scraping, and it just was a bit of a mess. So now the library is designed to actually have proper APIs, have proper interfaces, be able to be called from other Python programs and do the tasks it's supposed to do. And I'll come on to the other developer benefits in another slide. So just one of the best bits ever is that there is no more -- profile. You will never have to put -- profile into Volatility again. Yeah, when we first started doing this, we didn't realize quite how much of a pain that was going to be, but it's gone. So the latest version of Volatility 3 will now determine from your memory image. The auto magic has been drawn out, and it's an actual component of the tool that we use, so people can write their own auto magic and things like that. And it will now scan through and try and figure out whether it's a Windows system or a Linux system or a Mac system. And we have algorithms for identifying the kernel PDB and PDB GUID and age for Windows systems and the kernel banners for Mac and Linux systems. And we use those to key off which symbol tables we should be using. And of course, then once we load the symbol tables, we don't have to search for KD debugger data, so that's another speed up we get. We don't have to search for the KPTR or any of the bits and pieces like that, KPCR. And we can simply go, tell me where your active process head offset is supposed to be based on this kernel image, and it'll jump straight to it. And that gives us a real speed boost. And all of this data is in a text-based format because using Python code and allowing people to execute code in something that should really be static data also didn't seem like such a good idea. And that now means that there are a bunch of JSON files for holding the symbol tables, and that we've actually got code native in Python that will pull down PDB files and generate those for you if you don't have the pack already there. So even if you just download a copy of Volatility and you have no profiles or symbol tables or anything like that, you can just run it, and as long as it's got an internet connection, it'll figure out where the kernel is. It'll try and grab the PDB file from the thing. It'll take a little bit of time converting that into a profile, but it'll save it for you, so you'll never have to do it again. And then it'll run the plugin and tell you what it wants to know. One of the other things that we have now is support for multiple symbol tables against a single layer. So if you have a kernel layer and then suddenly you have an application, and the application is, for instance, 32-bit, such as WoW64, then you can have a 32-bit symbol table that has 32-bit pointers and 32-bit structures and all the other bits and pieces with it, and say, oh, within this application, I'm going to use these symbols to do all my analysis. And outside, even though it's a 64-bit kernel, I can still use the 64-bit symbol table to do all that stuff. And also this now provides us with the ability to do automated evaluation of in-memory code, which is a feature I will allow Andrew to take on because he's very excited by it. And so that's great for new users and offers you a lot of new things. But what's new for developers? So we've actually got documentation, and it's documentation generated from the Python code itself. So there's a read the docs page. It's got a few pages on how to convert Volatility 2 plugins to Volatility 3 plugins, and then it's got the entire API for all the interfaces, because we've provided interfaces this time. So now you can see, oh, I don't have to care about this particular object or that particular object. As long as it inherits from the object interface, everything's fine. And plugins have interfaces. All the components have their own little interfaces, so you can see exactly what they need to implement, what's supported and what isn't, what things you can do on there. We've tried to design it as a library. Plugins can now run other plugins. So in fact, the Timeliner plugin now just looks for other plugins that implement the Timeliner interface, and when it finds them, it'll run them. Thank you. So now, if you have a plugin that already exists that outputs timestamps, you can simply write a little bit of code that implements the Timeliner interface, and when you run Timeliner, it'll automatically get pulled in, it'll automatically get run against the system, and it'll automatically give you all of the various timestamps that you're after. Plugins are versioned, so before you might have had, oh, hey, here's this version of this plugin. Oh, hey, I've changed it slightly because now it's better. Oh, hey, I've changed it again. And then you'd have to tell your users, use my plugin, but you're going to need this other plugin, but don't use the latest plugin, use this one before that, but he hasn't versioned it, or he changed it, and so that's quite problematic, and what we've tried to do now is say, well, actually, let's have versions, let's have dependencies, and then you can say, well, you'll need this version, or you'll need that version, and Volatility will check for you that you've got that installed before it tries to run, so you don't have to worry about it going wrong. It's now also much, much easier to use custom data structures and to use symbols. So you can manually construct some JSON files if you want to. It's fairly readable. It makes sense. It's similar to the V-type language that was had in the past, but it's only data, so you can't have Lambda expressions or anything weird going on in there. And you can access all the symbols that your applications may have. So if your application says, oh, well, by the way, this critical structure, for example, TCP/IP.sys, which was always a pain because that kept changing at different speeds to the kernel, that can now have its own symbol tables, and we can generate as many of those as there are versions of TCP/IP.sys. We can probably generate them live. And that means that you don't have to worry about that anymore. It should just be one of those things that kind of is done for you, which is, again, what we were aiming for here. So one of the other nice new features, and there's a whole bunch of them, and I could run for hours about them, but another one of the big ones is this layering idea. So everything inside of Volatility now lives inside of a context. Your layers live inside of a context, your symbol tables live inside of a context, and your configuration data telling you what your plugin does and what it doesn't do are all within this context. And what that means is that you can have, previously, the AutoMagic in Volatility 2 would construct you a single linear list of this, change to that, change to the other, change to the other. And in Volatility 3, we said, well, hang on, you could have multiple data sources feeding a single memory image, for example, swap files. So we designed it to be capable of being a tree, and so that it could handle things such as the latest memory compression, which runs as a process, so you actually have to go kind of back up the tree a little bit. But the point is that all of these things can be looked after and maintained by Volatility without needing to build hacks in or change the way that the core works, because the core was designed to do this. To give you some idea of how fast this is, here's a graph that's almost certainly too small to see, but the concept is smaller is better. And the red bars are Volatility 3. The gray bars are Volatility 2, so you can see how much Volatility 3 outstrips Volatility 2 in certain areas. And the blue bars are recall, which the only reason that those big peaks go off the top is because this was run with recall in full scan mode, because they used a little shortcut to only scan bits of memory they thought were necessary. But when you actually scan all of memory, they fail on Windows 10 images in the same way that Volatility 2 did for a little while, which is Windows started implementing, we're going to map lots of memory, but it's all going to map to the same page, and it's going to be a dead page that's not going to have anything in it. And in Volatility 3, we had that from the beginning because we knew it was coming, and we've implemented slightly differently, which should give you, it's a little bit slower, but it should give you guaranteed never miss a memory page that could be important. So all of our Volatility plugins seem to run in kind of under 80 seconds. And that's definitely not the case with a whole bunch of other stuff. This is on the set of memory images we've got, which includes Windows 10, Windows 7, XP. XP is really fast. Yeah, no, it's just not. It seems not to be that complicated an operating system, I guess. But whatever it is, we just fly through that. So the point is that we've also got some Windows Server 2012 things. And some bits still need a little bit more optimization, but the point is we're getting markedly better results than any of the Volatility 2 stuff that's going on at the moment. As an example, this is actually not even running against an XP image. This is running against a Windows 7 image, and Volatility took 1 second to run that and produce the PS list output. And you didn't have to run image info before that. All of the stats from the previous slide, which I'll just go back to here, none of these include running image info. So all the Volatility 2 stuff and theoretically the recall stuff would have required that you know exactly which Windows profile you wanted to use. With Volatility 3, you just say, here's a memory image, go deal with it. And I think this is the last slide before I hand over to Andrew. We also have all of your old favorites. So Volshell is in there. It's had a bit of love. It has lots of functions for displaying types and all the things that you might expect from WinBag, and also a couple other bits and pieces to interact with Volatility and help you do that. And again, all of this stuff should be properly documented, have APIs, interfaces, and things, so it should be extensible. I'll now hand over to you.
And what I wanted to start with showing you is some of the features that are unique and some of the capabilities that are unique to Volatility 3. So these are things that don't really have an overlap or any corresponding features in Volatility 2. So they really incorporate a lot of the research we've been doing to kind of push memory forensics forward. So the first thing we want to be able to do was do analysis, especially in kernel mode, of beyond just the basic kernel. So if you look at how we build profiles in Volatility 2, how we incorporate those data structures, Volatility 2 really assumed that everything you cared about would be in the kernel file, the NTOS kernel. For Linux, it was very similar, and then Mac obviously was built the same way as well. So starting with Volatility 3, like what Eiklo said with the translation layers and so on, you have this ability to really take in types, so the data types you have and the symbol tables that you have of arbitrary modules. So when we look at the network stacks of Linux, Mac, and Windows, those are implemented in third-party kernel drivers. We didn't have a great ability to look at those inside of Volatility 2, but now this is something we can just do by default in Volatility 3. So in Windows, when you see rootkits that are hooking the Endis stack, which is pretty common, we can write all the plugins we want for that now. And it's the same thing on Linux when you have things that are hooking the netfilter subsystem, which is what drives IP tables. Again, we see a lot of rootkits in our real cases that do this. We can automatically have support and detections for this inside of Volatility 3. Something else we can do with bringing in the symbols is things like when we want to support applications like VeraCrypt and other third-party modules. If you had ever used our TrueCrypt plugin, it worked, but it was very sensitive and had to be kind of hand-coded to particular versions. VeraCrypt, which has replaced TrueCrypt since then, they actually distribute debug symbols the same way that Microsoft does for its kernels and Mozilla does for its browsers and tools as well. And we can incorporate that directly into the tool. So instead of having, if a new version of VeraCrypt comes out, instead of having to wait for us to update the plugin to do the analysis, we can just automatically pull those symbols for whatever version we're analyzing, and then the plugin can perform its tasks. Also in the output of all of the plugins where it makes sense, especially for kernel analysis, we include the symbols right away. So if you have done kernel analysis with Volatility 2, if you looked at the system call table, the callbacks, the IDT table, all of these areas of kernel memory that rootkits tamper with, in the past we would just tell you what module it came from. It would say something like NTOS or the network driver. Now what we can do is actually tell you the symbol that's implementing that. So you know exactly what part of that module is implementing the functionality, which lets you do much deeper analysis. And again, this is not something that we could really support in a sane way with Volatility 2. As Lycos mentioned, something we're working on as well is automatically emulating code in memory. So kind of briefly, if you look on the left, what you see is the output of Volatility 2's API hooks plugin. So what it's saying that this LDR load DLL function is hooked, it gives you kind of a static disassembly of what's there, and to figure out really what's going on, you'd have to hop into VolShell and then do some disassembly on your own, assuming you have reverse engineering skills. Versus what you're seeing in the column on the right, instead of just printing out the static disassembly, we're using our new emulation engine that we built on top of Unicorn to automatically emulate all of the code for that hook. And at that point, it tells you every region of memory it moved from, whichever DLLs it's moving through, and you don't have to have any reversing skills. So the tool can automatically make these pretty complex decisions for you because we're evaluating the code on our own. And so, like I said, with Volatility 3, you'll see that incorporated into a lot of the malware analysis plugins. Another thing we can do is allow you to analyze many memory samples at once. So I heard the reception for no more -- profile being needed. And this kind of shows that. So with Volatility 2, if I gave you a directory of memory samples and you didn't know what Windows version they came from and so on, you'd have to run kdebug scan or image info. You'd get the profile out of there. You'd have to set -- profile on the command line. And you'd have to do that for every memory sample before you could run a plugin. Versus what you see down here at the bottom, you can just run Volatility 3 directly against all the memory samples that you have. This is a very simple bash for loop that shows you how to do it. And you automatically get the results. So in this case, you can see the system process across the different memory samples. You could obviously automate this for any other tasks you have. If you have some IOCs that you want to run through with YaraScan, you can take however many memory samples you have and just scan them all at once. And then once it's done, you know which machines are infected versus having to do all these manual things on your own because Volatility 3 figures it out by itself now. As far as licensing for Volatility 3, starting with Volatility 3, the foundation will no longer release code under the GPL. So we now have the Volatility software license. This is a short, simple, plain language copyleft license. It grants all rights of copyright, requires any changes to the software to be shared, and it also covers content and data. Our advisor for this was Heather Meeker. She's one of the most prolific lawyers in this space, and we got some inspiration from the API copyleft license, as well as the Nmap public source code license, which a lot of people are probably familiar with, being that it's associated with Nmap. And then looking forward, because we've already started to get questions about this since we put the agenda went online for the conference. So the idea is from now, and the work we've been doing from now till August next year, so August 2020, we will be working on Volatility 3, trying to get it feature parity with Volatility 2. As of now, I checked last night, there's about 65 plugins in Volatility 3, where in Volatility 2 there's about 260 plugins. Now, that's not a perfect one-to-one comparison. We're not going to bring every plugin over. Some of the functionality is condensed, but you can see that we still have a lot of work to do. And so our goal is, by next summer, have the official release with feature parity, with Volatility 2, plus all of the new capabilities that we're planning to put in. As far as Volatility 2, we will maintain development and updates the same way we have through August 2021, so that's about 2 years from now. At that point, once we get to the summer 2 years from now, the core team will no longer develop or work on Volatility 2, and everything will be Volatility 3 the same way, all the features and all of our research going into it. So you can plan kind of your volatility usage around this chart. Which leads to one of our main takeaways is we would really like to get other people involved, other people helping. The community has been great to us for all the years, our trainings, our book, helping us promote new releases, coming out to conferences like right now when we're speaking. So there's a few things on here. One is we have the code on GitHub. Eiklos and Nick have spent a lot of time writing really helpful documentation. So we have official documentation here on the second link. And like I said, please get involved. If you want to take the new framework, run the existing plugins on it, give us any feedback if the output doesn't make sense, maybe you generate a crash or something like that, definitely let us know. We also have a ton of plugins still to write, so if you want to get involved, start writing plugins, start porting plugins over, this is a really good opportunity to do that. There's plenty of opportunities for research, development, helping us with documentation, usage, however you want to get involved, especially over the next year, would be extremely helpful, and you can make some great contributions. The other thing is, if you want to keep in touch with us, as of like yesterday, we started a Slack server for the volatility community. So all the open source stuff, the developers will be active here. That link, volatilityfoundation.org/Slack. This will auto join you in. You don't have to have approval or anything like that. And then we have our mailing list that's been around for a long time. So on Vol users, if you have questions, if you, whether it's Volatility 2 or Volatility 3, you want some help with analysis, just send an email, definitely let us know. If you want something more real time, definitely join our Slack server. So thank you for coming out to our talk. I think we kind of ran out to the time, so I don't know if we have time for questions, but all of us will be around for the rest of the night at the networking reception and out in the bar after. So definitely come by if you have any questions or want to speak with us. And definitely thank you for coming to our talk.
Cool.
Questions? Time for questions?
We do have time for questions.
Okay.
Any questions?
Oh.
Yeah. So the question was FreeBSD support?
We actually had the question, was FreeBSD support. We had a student who, I don't remember exactly, like maybe his master's or his senior thesis was working on it, so I feel like there will be some FreeBSD support. It's not our main priority right now, but we have someone outside the team who has put a good amount of effort into it, so yeah. Any other, yes?
PyPy or SciPy?
We have used PyPy, and actually I did some reference runs of Volatility 3 against that. They skewed the graphs massively, because if we were doing something with Python loops, PyPy really helped speed it up drastically. But if we weren't doing things with loops, or we were doing things that were mostly C-based, then it turned out that it actually added a huge amount. So it could be, it could skyrocket in places. So we've opted not to go with PyPy as a default. We haven't yet got around to transpiling it into other languages or doing C or Python or anything like that. But we are aware of it, and we'll keep looking at it if it becomes viable at some point.
Any other questions? If you raise your hand, we'll probably be able to see. All right, so thank you. We'll be outside in a few minutes if you want to talk to us in person.
Cool.